Example 1. Was Mendel wrong? Using table A-2 and StatCrunch. If one of Mendel's famous hybridization experiments, he expected that among 580 offspring peas, 145 of them, or 25%, would be yellow. But he actually got 152 yellow peas. Assuming that Mendel's rate of 25% is correct, find the probability of getting 152 or more yellow peas by random chance. That is, given n equals 580 and p is equal to 0.25, find the probability that at least 152 yellow peas. So, is 152 yellow peas significantly high? So we got to do the requirement check. Well, first we know that n is equal to 580 since that is the sample size. We know the probability is 0.25, and then we got to find the q, which is 1 minus 0.25, which gives us 0.75. So we get the following. N times p, which is 580, which is the sample size, multiply it by p, gives us 0.25, and that gives us 145. And n times q, which is equal to 580 times 0.75, gives us 435. So the requirements, meaning that is 145, which is n times p, is greater than or equal to 5, and n times q, which is 435, which is greater than or equal to 5, are both satisfied. Okay, so now what we need to do is we need to find the mean and the standard deviation needed for the normal distribution. So recall that the mean is equal to n times p, which is equal to 580 times 0.25, which gives us 145. And then we want to find the standard deviation. Standard deviation is the square root of n times p times q. So we have the square root of 580 times 0.25 times 0.75, and that gives us 10.4283. Okay, so now let's draw our bell curve, because now we know what is the mean of our distribution, and we also know what we need to look for. Okay, what we're looking for is the following. So let's put in our mean of 145. Okay, and what we want to find is 152 or more. So I'll put 152 down here, and that represents x. Okay, now we want the probability of at least 152 yellow peas. So the discrete whole number relevant to this example is x, which is equal to 152, which we have over here. And we want to identify the discrete whole number x that is relevant to the binomial probability problem being considered, and then represent that value by the region bounded by the following. So we're doing the continuity correction. We have x minus 0.5 and x plus 0.5. We know that x is equal to 152. So if we take 152 and then subtract 0.5, that gives us 151.5. And if we take 152 plus 0.5, that gives us 152.5. But since we want to find out what it is to the right, then we want to use this value here, which is 151.5. So what we're going to do now is we're now going to draw our value of 151.5. Okay, and then just so that we know, well, let's just label where 152.5 is. So 152.5 is going to be on the other side here. Okay, but since we're looking for 152 or more, then what we're interested in is the area that is to the right of 151.5. So what we're doing is we're using that approximation. So instead of using at 152, we're going to go one below that to be 151.5. So now what we were going to want to do is we want to find out, since this is the X scale, this is the Z scale. So we know that 0 represents the mean for the Z scale. And so what we want to do is we want to find the value of here that represents Z. So now we want to find that Z-score associated with the value of 151.5. So if using table A-2 or StatCrunch, which we're going to do both, we must first find the Z-score using X to be 151.5, the mean to be 145, and the standard deviation to be 10.4283. So we're going to plug in our values to find the Z-score. So we know the mean is the value of X is 151.5. We know that the mean is 145. And we know that the standard deviation is given to be 10.4283. Now when we divide that, we want to round this to the nearest 2 decimals, which gives us 0.62. So now we can label on our graph 0.62. Okay, so what we want to do is we want to find the area that's to the right, but remember that in our table, it's going to give us the area that's to the left. So if you take a look at the value of 0.6, and then we're going to go up and find 0.02, that's going to give us the area that's to the left of that. And so the area that's to the left is 0.7324. Now the area to the right is going to be 1 minus 0.7324. So here, again, we find that the area to the left is 0.7324. And so the shaded region in the bottom portion of the figure is going to be 1 minus 0.7324, which then gives us an area of 0.2676. Okay, now how do we do this on StatCrunch? Well, if we open up StatCrunch to find the area there, then what we would do is go to Stat, go to Calculators, and then we're going to go to Normal. Okay, and then we want to make sure that we have the mean of 0, the standard deviation of 1, and then we want to make sure we're going to use the greater than because we want the right side, and then we're going to put in our Z-score of 0.62, and therefore we get that result. So you can see here that using StatCrunch gave us the same result of 0.2676. So what we can do now with our interpretation is the following. We would say that Mendel's result of 152 yellow peas is greater than the 145 yellow peas he expected with his theory of hybrids. But with the probability of 152 or more yellow peas is 0.2676. So we see that 152 yellow peas is not significantly high. That is a result that could easily occur with a true rate of 25% for yellow peas. So this experiment does not contradict Mendel's theory.